Hello everyone, hope you all are doing well. So in today's video, we will be solving our blind series 35th question, which is insert intervals. So in this question, we are given an array of non-overlapping intervals, and each interval has 2 points. First of all, first is starting point and the ending point, and these intervals are sorted in ascending order. And what we have to do is we have given a new interval, and we have to insert that new interval into our intervals array in such a way that it maintains the sorted order, which is the ascending order. And if in case if there is overlapping occur, so we just have to merge those interval where the overlapping has been occurred, and at last we have to return the interval after the insertion of the new interval. Let's see how can we approach towards the solution. Before moving to the solution, let's understand what is overlapping and non-overlapping intervals. Okay, so let's consider this case. We have an interval which starts from 1 and end at 5, and another interval which starts from 3 and end at 7. So as you can clearly see, it is a overlapping interval because the second interval starting point, which is 3, lies between the first interval, in between the first interval. As you can see, the 3 lies between 1 and 5. That's why we consider this as a overlapping interval. Or you can say that the ending point of the first interval is greater than the starting point of the second interval. So it can also conclude that the intervals are actually overlapping. Okay, and to resolve this overlapping, we simply merge these intervals. And how we do that? We simply consider the minimum of the starting point of these both intervals. So the minimum of both interval starting point is 1. So the new interval that will be created after the merging, its starting will be 1, and for the ending we take the maximum of the endpoints of these both intervals. And what is the maximum here? 5 or 7? Here the maximum is 7. So the new interval ending point will be 7, and the new interval that will be created after merging these both interval will be 1 to 7. Okay, and for the second case here, we have a starting point from 1 to 2 and the second interval from 3 to 4. As you can clearly see that 3 doesn't lie between 1 to 2. So we can say that these intervals are non-overlapping intervals. Okay, here the ending point of the first interval is less than the starting point of the second interval. That's why we can conclude that these intervals are non-overlapping. And if it is 2, okay, if let's say if this interval starts from 2, so this is also considered as overlapping because it just lies on the ending point of the first interval. So this also considered as overlapping, and the new interval that will be formed after merging will be 1 to 4. Applying the same criteria of merging, the taking the minimum of the starting point and the maximum of the ending point. So this is all about the concept of non-overlapping, merging, and overlapping intervals. So let's move towards the solution part. So to solve this problem, I divided this problem into 3 cases, and these 3 cases shows the result that can be occurred when we compare any two intervals, specifically the interval which is already present in the array, and the second one is the new interval. So let's see one by one each case. So the first case is when the current interval ending point is less than the new interval starting point. So in that case, we can simply push the current interval into our result. For example, let's say our new interval is 5, 6 and the current interval is 1, 2. So in this case, as you can see, our current interval is actually smaller than the new interval. So we simply push this particular interval into our result. We don't need to compare it any further because we already know that the new interval is larger than this interval. So no merging will be occurred and they are non-overlapping intervals. So this is all about the first case. And in let's see the third case. In third case, we have if the new interval ending point is less than the current interval starting point. It means our new interval is actually smaller than the current interval. For example, in this case, here our new interval is actually smaller than the current interval. Let's say the current interval is 7,8. Here the starting point is 7 and here the new interval ending point is 6. So it is obvious that these intervals are non-overlapping and this new interval should come before this current interval. So there also no merging will be occurred as there will be no overlapping between these intervals. So simply I will push this new interval, then I will push all the remaining intervals that comes after that. And at last we have the case 2. It is where we will handle all the overlapping interval cases and merge them. For example, let's say here we have, let me erase this. Let's say here we have 5 to 8 and 3 to 6. If we consider these both intervals, this is the new interval and this is the current interval, so they are overlapping. As you can see, the 5 lies between 3 and 6. And for case 2 here I have written, okay, this is the same as the case third. If the new interval ending point is smaller than the current interval starting point, it means the new interval is smaller than the current interval. In this case, it is simply come before the current interval, this new interval. But otherwise, if my current interval starting point, this is the starting, it is 5. Okay. If it is smaller or equal to the new interval ending point, this one. So I will simply merge this both interval. As you can see, the my new interval starting point is actually smaller than the new interval ending point. So we will merge this both interval. And how we will merge it? We will take the minimum of both this interval for the starting point. So here 3 will become, and we will take the maximum of the ending point of this both interval. So here it is 8. So our new interval after merging will become 3 comma 8. So that's how we will approach towards our problem. And for so on, let's say we have the next interval is 8 comma 10. Okay. So here in this case, our new interval is this now, and the new interval, the current interval is now 8 comma 10. So here also, as you can see, the current interval starting point is 8 and the new interval ending point is 8, so it is equal. So in this case also we have to merge this both interval. So after merging, our new interval will become 3 comma 10, taking the minimum of both this starting point and taking the maximum of both this interval ending point. So the new interval will become this 3 comma 10. Okay, now let's say if the next interval will come 12 comma 15, let's say this. So in this case, we can simply see that the current interval starting point is actually greater than the new interval ending point. So in this case, it is obvious that the new interval will come before this particular current interval. Okay. So in this case 3 will be occurred. Okay. This case 3 will be followed. So whenever this condition will be true, this third case condition will be true. So at this time we simply have to push all the rest of the intervals, because we already know that the array is already non-overlapping, is filled with non-overlapping intervals. So that's how we will solve our problem. We just have to see the second case, because the first case and the third case is simply, we have to, in this case we simply have to push the intervals, and the main merging will be only done at the second case. So let's move towards the coding part. Okay, before starting to code, let me shout this interval and this new interval to in and ni, because I'm a lazy guy and I don't want to write it again and again, the whole interval and new interval. So let's get, first of all, let's get the size of the interval by size function, and let's create a vector of vector int our result, where we will be storing our result intervals. Okay, now I will initialize the I from 0, and let's say first of all we will code it the case 1. Okay, the case 1 part. What was the case 1? The case 1 is the part where the new interval is actually larger than the current interval, like in this case here 1 2 is smaller than the new interval. So in this case, we simply push this particular interval into our result. So let's first of all check that whether our index is actually out of the bound or not. Then we will check the condition. Okay, that our current interval last index. Okay, the current interval last index should be smaller than the new interval starting index. Okay, if that's the case, here the current interval ending index should be smaller than the new interval starting index. So in this case, we simply have to push the current interval into our result. Simply push the current interval. Okay, and I will increment my ith index, and I will go to the second index. Okay, this will handle all my cases where my new interval is larger than the current interval. Okay, now let's code the second case, and this is the case where the actual merging will occur, like here. Okay, so first of all, we will check whether our index is in the bound or not, because obviously. And now, what's the condition for overlapping? That was the the current interval. The current interval starting should be less than or equal to the new interval ending point. Okay. For example, let's say the new interval is our current interval is this, and its starting point is 3. Okay, and the new interval ending point is 8. And as you can see, the new current interval starting point is actually less than the new interval ending point. So it means there is an overlapping occurred in between them. So what we have to do is we have to merge this interval. Okay. So for merging, we will take the minimum of the starting intervals of these both intervals, and will merge the merchant resultant will be in the new interval. So we will take the minimum of the both of the starting interval and the current interval, and for the ending part we will take the maximum of the both of the interval ending point. Okay, so it will handle all the merging of the intervals. So let's see this case, like in this case, here the merging will be occurred and the result will be 3 comma 8. The new interval will become 3 comma 8. Okay, so now 3 comma 8 will be compared to 6 comma 7. So here also the same case 2 will be occurred, because the current interval starting point is actually less than the new interval ending point. Okay, so here also merging will be occurred, and the new interval that will be updated will be 3 comma 8 only, because the smaller of from both of these is actually 3. This here will be 3 because from here we get to 3. Okay, so this will also be 3. This will remain as it is, 3 comma 8. Now it will be compared to this one, this interval, and here you can see that 3 comma 8, this 8 and this 8 is actually overlapping, so it is also merged, and the new interval will be updated as 3 comma 10. Okay, so the new interval will become 3 comma 10, and at last it will be 3 comma 10 will be compared to this, and at this time the starting of the current interval is actually greater than the ending of the okay, this one, ending of the new interval. Okay, ending of the new interval. So this time this will be this third case that we have to write. The third case will be occurred. Okay, the third case is okay, we also have to push the new interval. If this condition is not satisfied, it means the new interval should come before that. So so we will push the new interval in our answer. Okay, before pushing all the intervals after this, we have to push the new interval in our array before pushing all this. Okay, so here like this, we will push first of all the 3 comma 10 in our interval, the new interval. Okay, then the case 3, at case 3 we simply push all the intervals after it, because we know that our array is already shorted in ascending order. Also, they are not non-overlapping. So we already inserted our new interval, and finally we have to just insert all the interval after the new interval insertion of the new interval. So we just simply have to insert all the rest of the intervals. Okay. Here also I have to increment Ri. Right. Okay. And at last I have to return the result. So let's try to run this. Okay, it's giving me the right answer. So let's try to submit it. So it got submitted, as you can see. Okay, so this is all about, we only have to handle this second case, and the first case and third case is very simple. We just have to push the interval because we doesn't have to consider any merging or non or overlapping cases. So if we talk about the time complexity of this code, the time complexity of this code is simply O of n, because the while loop is actually running only till the size of this current interval, and each time we only checking whether the interval is overlapping or not. So it is only O of n. Okay, so that's all for today. You will get the source code of this in the GitHub. You can check the description for the link. So I will meet you on the next video.